All right, in the waves unit, there's some really dense theoretical stuff that's not, I would say, overly important for your understanding in Physics 30. We will cover it just for the purposes of completeness. So just before we get into this, let's just talk about some, and this is looking at the reflection of waves between different media, so going between two different types of media. So incident wave is going to be the original wave. The transmitted wave is the wave that will continue into the new medium, and the reflected wave is the one that's going to bounce back in the original medium. So hopefully these terms will make more sense when we have some diagrams. So the wave behavior is going to change depending on the medium that the interface is interacting with. So, and before we even get to the changing of media, we're going to look at just when we're sticking inside the same medium. So the first bit here is fixed end reflection. So if we have a string, we produce a wave. This end here, this is going to be fixed. What's going to happen is this wave is going to make its way here, and then we're going to have a reflected wave. You will notice that the reflected wave is inverted. And the good question is why? Well, this happens to be a Newton's third law bit. So when this wave gets this fixed point, it's going to try and pull up at this point. The problem is it's not going to be able to move anything because this is anchored in place. By Newton's third law, if this string is trying to pull up at this point, this wall fixed at this point is going to pull down on the string. So when the wave gets to here, now the wall is going to apply that equal and opposite force. It's going to pull it down, and what it's going to do is it's going to generate that inverted wave pulse. Now, the thing you want to keep in mind is that the two pulses have the exact same speed. They're traveling in opposite directions, but their speed is the same. The reason for that is the speed is determined by the medium. The medium has not changed, so they are going to have the same speed. Some of the energy is probably going to be transmitted into the wall to cause like very, very tiny vibrations. So you'll notice the amplitude of this returning wave or this reflected wave is probably a little bit decreased. But that, and yeah, it's just because some of that energy loss. But amplitude changes do not affect the speed. The speed is dictated by the medium. The other thing that we could look at if we want to stay in the same medium is this thing called free end reflection. So this time, the end here, it's free to slide up and down this pole. So when we generate a wave, what's going to happen is we're going to generate that incident pulse. The reflected pulse is also going to be upright. The reason for that is that when this free end slides up, once this wave gets here, this free end is going to slide up and back down. It's going to kind of mimic the hand movement. So when it goes up and back down, it's going to generate this reflected pulse that's upright. Just because the movement of this free end, now that it can move, it's going to mimic the pulse exactly. The only difference is we're going to send it into the opposite direction. And again, the speeds of these two things, they should be exactly the same because they're in the same medium. And like here's just kind of a diagram showing that difference between fixed end and free end. So here's our fixed end, the waves coming in. Now you'll see that inverted pulse being generated. Whereas in the free end here, you'll kind of see it approaches this free end, and then it kind of gets a little messy here, and then we're producing that pulse that is going back, the reflected pulse. Now, fixed end and free end reflections deal with the case of staying in the same medium. What we'd like to do is we'd like to see what happens when we decide to go between media. So the first case is if we happen to be going from a low density to a high density medium. So we're going to have our incident pulse. It's going to travel along. It's going to get to this interface or this boundary. So there's going to be a transmitted pulse into the more dense medium. And then there's going to be this reflected pulse that happens to be inverted. So the transmitted pulse, it is going to travel at a slower speed. Since this is a more dense medium, when we go to a more dense medium, the speed's going to go down. The wavelength is also going to go down. So you'll notice that the wavelength, this distance is actually half of a wavelength, but you'll notice that it's much shorter than here. So we are decreasing the wavelength and decreasing the speed, which we expect going to a more dense medium. And our reflected pulse, it's going to have a smaller amplitude than our incident pulse, and that's just because energy has been transferred to the new medium. So some of that energy has been lost, which is going to be reflected in that inversion of the pulse. Now we're going to ask, why is it inverted? It's kind of very similar to the case with fixed end reflection. When this wave gets to this point here, it's going to try and pull up on this really dense string, but it's not going to be able to do too much. Like, it's going to be able to generate certainly a wave in here, but if this light string is going to pull up on this dense string, we know by Newton's third law this dense string is going to pull down on here, and that's going to be a significant pull just because of that density difference. So when it pulls down, it's going to generate that inverted pulse. And we explain all of that in here. Now, the last case that we could look at is if we kind of look at the complete opposite. If we go from a more dense to a less dense medium, we have our incident pulse, and then we have our transmitted pulse. You'll notice the wavelength has increased because we're going to a less dense medium. Speed's going to pick up, which means the wavelength is going to pick up. So our incident and reflected pulses, you'll notice there is a difference in amplitude, again because that energy has been transmitted into this pulse. The incident and reflected pulses will still travel at the same speeds because they're in the same medium. And again, we're going to have that reflected pulse that happens to be upright. This is kind of similar to like the whole idea of free end reflection. Like when this really thick rope moves up, it's going to move back down. It's going to be able to kind of easily mimic this pulse right here. This whole transmission between boundaries, like I said, it's not a really important point for Physics 20. Like if you don't get this, you'll be fine in the course. It's just something we want to bring to your attention.